So now we're going to do the problems, the odd problems on page 103, starting with 65. So here is, and you can look at your book too while you're doing this. So we have to figure out what the pattern is. So, in order to determine what the pattern is, we have to look at the relationship between n and the value of the expression. So if n is 0, then the expression is -1. So that right there tells me, because we know that anytime you multiply anything by 0, anything by 0 is 0. So, so that tells me that because the value of the expression when n is 0 is -1, that tells me that there's going to be a -1 as part of the expression. So it's going to be something times n -1, because no matter what this number is here, the coefficient, if the coefficient is 0, if n is 0, no matter what this is here, our value is going to be -1. So we tell that right away. So then, but if n is 1, then the value of the expression is 1. If n is 2, then the value is 3. If n is 3, then the value is 5. If n is 4, then the value is 7. So I'm noticing, do you notice that the difference between all of the values is 2? From -1 to 1 is 2, from 1 to 3 is 2, from 3 to 5 is 2, from 5 to 7 is 2, but n is just going up by 1. So the only way that that can happen is if the coefficient is 2. 2 times n minus 1. So let's test it out and see if it works. Well, we already said if n is 0, 2 times 0 is 0, minus 1 is -1. So what if n is 1? 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 2 times 5 is 10, minus 1 is 9. So that's the expression, 2n minus 1. Let's look at number 67. Okay, so in exercises 67 and 68, find values for a and b such that the expressions an plus b yields the values in the table. Okay, so this is a little bit different. We need to find the values of a and b for these n's. So an plus b so if n is 0, and we know again, remember that anything times 0 is 0. So that helps us here in this problem. Oops, sorry, can't see that very well. Because when n is 0, and so it doesn't matter what a is, but when n is 0, look, the value is 4, which means b has to be 4. Okay, so now if b is 4, now we can use the n in the next value to solve for a. And then we'll just test it and see if it works. I hope this is making sense. If this doesn't make sense, ask me a question. Post a question and I'll answer. Okay, so if n is 1, something times 1 plus 4 equals 9. So here, I'm going to write that over again down here. So some number times 1 plus 4 equals 9. Okay, so a times 1 is just a, right? So a plus 4 equals 9. And just like with any algebraic equation that we need to solve, we subtract 4 from both sides, then a equals 9 minus 4 is 5. So now we know what a is. So we can go back up here, and we know that that's 5. So now we know our equation is 5n plus 4. Now let's see if it works. Let's test it with some of the other problems. Okay, so let's test it with 2. So if n is 2, 5 times 2 plus 4, does that equal, let's see, it's supposed to equal 14. Let's see if it does. 5 times 2 is 10, plus 4 equals 14. Yes, it works. Yay! So that's the answer. Okay. All right, how about number 69? Can we see that one? Okay. And I'll just do like 3 problems, I guess, per video. Then that way you can just watch the ones you need to watch. Okay, so in exercises 69 and 70, draw figures satisfying the specific conditions. The sides of a square have length a centimeters. Draw the square. Draw the rectangle obtained by extending 2 parallel sides of the square 6 centimeters. Find expressions for the perimeter and area of each figure. Okay, so it sounds way more complicated than it is, as most of this stuff does, right? All right, so I don't have a template or a ruler with me right this second, so my drawings are going to be not perfect. So we're just going to, I'm going to do the best I can. So the sides of a square, so I'm going to draw my square. And they have the length of a centimeters. And these are all the same. So that's a centimeters, this is a centimeters, this is a centimeters, and this is a centimeters. Okay? All right. Draw the rectangle obtained by extending 2 parallel sides of the square 6 centimeters. Okay, so now I'm going to draw my rectangle. I'll just draw it right underneath because I think that would be easier to see. Here's my rectangle. Okay, so this is still a centimeters right here. That's still a centimeters. But these 2 sides here, those 2 sides are going to be 6 centimeters larger than a. So that means it's going to be a plus 6 centimeters. A plus 6 centimeters. A plus 6 centimeters. Okay, so now find the expressions for the perimeter and area for each figure. Okay, so we know, because we know that area is length times width. So for our square, the area is going to be a squared, because a times a, that's the area. And then our perimeter for our square, for the square, is going to be 1a plus a plus a plus a. So it's going to be 4 times a. Okay? So the areas of the square is a squared. The perimeter of the square is 4 times a. All right, now let's look at our rectangle. So our rectangle is going to be again, area is length times width. So the length times the width of our rectangle is going to be A times A plus 6. That's going to be our area. And we're going to simplify it because we can. So that equals the area. So A times A is A squared, and then A times 6 is 6A. So A squared plus 6A is going to be the area of the rectangle. Okay, now we have to figure out the perimeter. So the perimeter is going to be A plus 6 plus A plus A plus 6, or 2 times A plus 2 times A plus 6. So 2A, 2 times A, plus 2 times this quantity here. So we're going to simplify this also. So that's going to be 2A plus 2 times A is 2A plus 2 times 6, which is 12. And then we're going to simplify that even more because we can combine our like terms. 2A plus 2A is 4A plus 12. So 4A plus 12 is our perimeter of the rectangle. Okay? And that's it.